Welcome back, and I hope you have been able to create your training pipeline by now. And now let's see how we can create an inference pipeline and then deploy it as a web service. So once you have run your training pipeline successfully, you will see this extra option of create inference pipeline available over here. All you need to do is click on it, and then it will provide these two options of creating a real-time inference or the batch inference pipeline. For now, let's create a real-time inference pipeline, which will do the predictions in real time using a web service. So click on it, and please wait while it creates the inference pipeline. It could take from few seconds to a couple of minutes. And once it has created the real-time inference pipeline, you will see that Azure has made few changes to it. The first and the most visible change is this web service input and the web service output that it has created. Then the two-class logistic regression module as well as the trained model is gone, and it is now replaced by this trained model. Then even the clean missing data is now replaced by this cleaning transformation, and we simply apply this transformation to the input data. Then we also don't have the split data module. It is no more required because we will now be dealing with the real-time data for prediction. But before we actually run this and deploy it, there are a few changes that we need to do to this inference pipeline. First, if you click on this select columns dataset, you will see we are selecting the loan status as well. Now, because our web service input is connected over here, it will require all the parameters that is being selected by this module as the input schema, and that will include the loan status as well. But that is what we need to predict, and we cannot have that during the prediction run or real-time run. So first thing is we need to get rid of this loan status. So click on this edit column link, and then remove the loan status from here. Great, save it. And then we are also going to remove the web service node from here. And that way our endpoints will not expect the loan status as part of the input. And instead of that, let's connect it to this node of apply transformation, where the output of this select columns is connected. So now our endpoints will also have the input schema without the loan status. Then if you come down, we don't require the evaluate model now. So we can simply click on it and press the delete to delete it. That's it. For now, it looks good. But just to save some cost, I have deleted one of the clusters that we used for model training and scoring. For now, I'm going to use the default compute target for all the modules. So I'm going to go to the score module, and then in the run settings, I'm going to select the default compute target. Also check the other modules as well, just in case we may still have it. Everything looks good, so hit the submit button. And let's now provide the same experiment that we used for training. The compute is the default one, of course. So hit the submit again, and it will submit the inference pipeline run for you. Wait for some time, and it should be done in a couple of minutes. So as always, I'm going to pause the video and come back once my inference pipeline has finished running. Great. It is done with running the inference pipeline. And now, if you click on this score model module and visualize the output of it, you will see that the output schema contains the input columns as well as the scored labels and scored probabilities. And because our web service output is connected to this node, it will return all these columns as key value pairs. But as a good design, you may want to limit the information that you return. You may want to just pass on the scored labels and its probability. Scored label is nothing but the actual prediction of whether the loan should be approved or not. So for that, we can bring in another select column module. So search for it and then drag and drop it on the canvas. Then let's connect the output of the score model to the select columns and remove this output going to the web service output. And instead of that, let's pass on the output of the select column to our web service output. All right. And I hope you should not have any problem in understanding what's going on here. Basically, we are going to select just the scored label and scored probabilities in this select column module and then pass it on to our web service output. So click on this select column module, click on the edit columns link, and then by name, and select just the scored label and the scored probabilities. Click on save again, and now we can submit this run again because we have added this extra module over here. So click on it, provide the same experiment, and submit it again. And don't you worry, it saves the results from the previous run, so it may not run all these modules again. It will be pretty quickly done compared to the original run. There you go, it has finished running it. So congratulations on completing the inference pipeline run. And now we are ready to deploy this experiment as a web service. But before we do that, there are some minor changes that we need to do before we start using it. And it is mostly related to the allocation of the compute target or the Kubernetes cluster creation. Remember, for real-time web service creation using the designer, we require a Kubernetes cluster. So in the interest of time, let's do that in the next lecture. Thanks for watching, and I hope you are enjoying this as we get closer to real deployment. Welcome back, and now that we have created our training pipeline, ran it successfully, and then even created and ran the real-time inference pipeline, let's deploy it for predictions. And for that, you need to simply click on this deploy button. And then in this dialog box that it will open, it will ask you to provide some deployment details. So it is going to be a new deployment. Then it asks for the name of the endpoint as well as its description. But the most important of all is the compute type. And for that, we will require an Azure Kubernetes cluster. So far, we have not done that. And that is why we won't be able to deploy it. So let me cancel this first, and then let's first go ahead and create an AKS cluster. So for that, let me go to the compute in this new tab. I have just opened a new tab of the Studio interface. And then within the compute, go to inference clusters and click on create. Again, it's a set of pre-configured virtual machines. So the setup process is same as the compute cluster. The default option here is for the new service. Then you select the region, and I'm going to select the region as West US, and then wait until it loads all the available virtual machines for this service in that region. It will also show you the available quota that you will have. So select any of these machines with 8 or 16 GB of RAM. That should be good enough. Click on next, give a compute name, and I'm going to provide the name as AML-EP-K001, EP for endpoint. And then as you can see, it does not allow this cluster to be used for production purpose. For production endpoints, it requires minimum of 12 cores or 12 virtual CPUs. So either we use a very high configuration machine or use multiple machines or nodes so that the total available cores are 12 or more. Alright? And because we are going to use this for just our own training and development purpose, I'm going to select the purpose as dev test. So the moment you do that, this error is gone, which is great. We won't have to spend a lot of money unnecessarily. Then leave all the other options to their default values. So it will simply create the Kubernetes service with just one node, which is fine for development and testing purpose. Then click on create, and it will submit the provisioning and start creating the cluster for us. Like any other virtual machine or compute machine, it may take some time. So I'm going to pause the video and come back once it is done. So after almost 4 minutes, it is now provisioned for me. So let's go back to our inference pipeline. And now we are ready to deploy it. So click on this deploy button again and give some name to this endpoint as lone EP001. Then select the compute name of the AKS service that we just provisioned. In fact, that should be the only available one if you are using the free subscription and have been following me. And then hit the deploy button to deploy it as our endpoints. It will then start preparing for the deployment, then creating the endpoints for our model. And finally, when it is done, you will see a message that the deployment is successful. Again, it may take a little bit more time. Unlike the compute and the Kubernetes clusters, it would be done relatively quickly. So it could be a minute or so. But again, thanks to video editing, I can pause the video and you will feel as if it is finished in a flash. So congratulations, as our deployment is now successful. And you can click on this view real-time endpoint to get the details of it. And there you go. It has displayed various attributes of it. The most critical one is the deployment state. It shows healthy over here, which means it is in good condition. And we are ready to use it or consume it. And if you want to test it, simply click on test And as you can see, it has these input parameters of married, education, and so on, all the way until the credit history. So let me come up and provide the married as true. Remember, we changed the data type from string to Boolean. Then let the education be graduate. Self-employed again, let me type true. The applicant income can be 5849. And let me change the loan amount to 234. Let other values be to their defaults. Then scroll up and click on test to see the web service output. And there you go. It has provided this score label as a true, which means the loan should be approved, and it has given this scored probability over here. And it provided only these two because after the score model module, we have chosen to select just these two columns. If you want to pass on something else as well, you can do that using the select columns. Great. And I'm sure you must be feeling very excited if you have been following me. Hey, but this is just the testing within the interface. You can always use it in your application or some program as well. And for that, simply click on consume. And there you have the basic consumption information. So it has this REST endpoint, which is nothing but the URL, which you will have to access in order to send the input. Then you also have the primary and secondary authentication keys, as well as the sample code to consume this web service. As of now, it shows the code for C#, Python, and R programming, and I hope very soon it will also give you a sample code for Java or Ruby or any such. But if you have any programming knowledge, you can very easily code this in your program. And those who are new to programming, do not worry. There is a crash course on Python basics in one of the sections of this course, and that should be good enough for you to get started with the coding. And when we actually use that code for Azure ML SDK in a dedicated section, I will show you the demonstration of it as well. But for now, it is good enough to know how to create, deploy, test, and consume our predictive model as a web service. So congratulations on learning some major outcomes required for the DP100 exam, and also understanding the full cycle of pipeline creation and the deployment using Azure ML Designer. I hope you have enjoyed learning it as much as I have enjoyed every bit of teaching it to you. As always, it's a pleasure to teach you. Thank you so much for joining me here, and have a great time. Welcome back, and today let's now see another exam objective of create a pipeline for batch inferencing. And within that, we will see the sub-objectives of how to run a batch inference pipeline as well as publishing a batch inference pipeline. So let's go to the designer pipeline and see what we have got. So here I have already created a pipeline for the loan data and also ran it. It's very similar to the pipeline that we built earlier for real-time inferences, but it has a small change. Now, instead of using the full loan predictions dataset, I'm using just the 500 records from it for model building purpose. The remaining 100 odd records will be used for testing the batch inference pipeline. Then rest of the steps are exactly same as we did earlier. We select all the columns except the dependents, co-applicant income, and the property area. Then apply the missing value replacement on them, and then finally split the data, train the logistic regression model, score the model, and finally evaluate it. I'm not going to deep dive into each of these as we have already seen them. What I'm interested in is showing how to create a batch inference pipeline. So for that, click on this button that says Create Inference Pipeline, and then click on Batch Inference Pipeline. And you may have to wait until it does its stuff. So basically, some of these modules will be removed and some will be transformed into some data transformations and trained models. So we have the clean missing as a transformation, then the trained model over here, similar to the previous one. And now here you don't see the web service input and output created. And that is because it is expecting a dataset as input parameter, and the output will again be the dataset with predicted values. So for that, we need to make this input dataset as a parameter to the pipeline. So click on it and you will see this checkbox that says set as a pipeline parameter. Check it, and now it requires the name of the parameter. So provide some meaningful name such as loan input. That's the first change that we need to make before we convert this trained model into a batch inference pipeline. Then in the select columns, once again similar to real-time inferencing, we should not have the loan status because that is what we are going to predict. So click on edit column. and remove the loan status. Save it, and everything else until the score model is now fine. Then same as the real-time inferencing, we don't need the evaluate model. So simply delete that. And now let's go to the training pipeline first, as I want to discuss the score model first. Now, the score model module is going to provide a dataset that will have the original data as well as 2 additional columns of scored label as well as the scored probabilities. Now, in case of real time, we were okay to just select these 2. But for batch, it is possible that we may want to keep the entire dataset stored separately somewhere as an output. Maybe some other program or job wants to use that for further processing. And let's say we want to store this output in our storage account as a different file. And that means we basically need to add some script or module that will take the output of the scored dataset and store it for us. And if you remember, we have the export data module to do just that. So simply search for it, drag and drop it on the canvas, and then connect the output of the score model to the input of the export data. And now let's provide the path where it can save it. So choose the Azure Blob Storage as the data store type. Then our data store of Azure ML DS01. And now this path parameter here is a bit tricky. You may experience some issues typing in space if you have that in your path. So I'm simply going to copy and paste the path over here. So that is loan data / loan batch predicted.csv. And the file format as CSV as well. That's it. So now when we run this inference pipeline, it will expect a new input dataset as it is set as a parameter. Then after applying the transform and predicting the result, it will store the output in this file specified as part of the export data module. So now let's submit this inference pipeline for the run before we can deploy it. So simply click on the submit button for that, and it will ask you the same details such as the experiment, etc. So select the loan batch and hit the submit button to run it. Again, depending upon the kind of compute cluster you have selected, it can take anywhere from 5 minutes to 15 minutes. So please be patient while it runs, and I usually keep a minimum node as 1 so that it does not take a huge amount of time in provisioning it. For now, let me pause the video and come back once it is done. Everything went well, and now let me go to the Azure portal and let's see what has happened to the container. So here I am to the loan data folder inside the blob container, and you will see this additional file of loan batch predicted.csv created over here. You can click on it, and then if you want, you can even download it and then check the output. It will be exactly same as the output of the score model module. Great, and now we are ready to publish this pipeline as well. But in the interest of time, please allow me to do that in the next lecture. I hope you are enjoying learning and creating these pipelines using Designer. Once again, thank you so much for watching. Welcome back, and I hope you have created the batch pipeline and also ran it. And it is okay if you have not. You can wait until this lecture is finished and then do everything in one go. So now, to publish and deploy this pipeline, we simply need to click on this publish button. Then in this new dialog box, click on create new, as we don't have an endpoint for now. I'm going to leave this name as it is and also leave rest of the options to their default values. And again, click on publish. The Azure will start doing its stuff of publishing and deploying it. For this one, you don't need the Kubernetes service. You can deploy it using the compute clusters that we created earlier. And once it is done, you will see this message that the pipeline has succeeded. And let me click on this link here to go to the inference endpoints. And there you go. Our batch inference pipeline is very much published and deployed. Under the details, you will see the modules within the pipeline, but they are all read-only. So you cannot modify or change anything in this view. You will also see the endpoints of this pipeline for the batch run. And we are now ready to test this inference pipeline endpoints and then see how it can make predictions in the batch mode. For that, simply click on submit button over here. And then in this dialog box, select the existing experiment of loan batch. The description here is mandatory. So let me type in loan batch first run. And now let's change the input dataset from this loan 500 to loan 100. So when you click here, you will see all the datasets that we have created. So select the Loan 100 and then hit the submit button to test our endpoints for the batch submission. Then you will see this message of pipeline run has been submitted. Click on view details. And then on the next page, you will see this pipeline run. Under the graph, you will see our flow and their status. Once again, I'm going to pause the video while it is running and come back once it is finished. And there you go. It has finished running. And now when we go to the storage account and let's also go to the loan data folder. And here you will see this file of loan batch predicted. Click on it and then click on edit. And you will see the scored output of our batch pipeline run over here. Great. And now you can copy it, download it, or use it in any other application that you want to. All right. And now you know how to create a batch inference pipeline as well as how to publish it and export the scored dataset to the storage account. And if you have been doing it along with me, congratulations on completing your first batch inference pipeline. I hope you have enjoyed it as much as I enjoyed creating it. Now, before we end this lecture, if you don't plan to use these resources beyond this time, please delete the resource groups by going to the Azure portal, go to resource groups, and then delete them right from here. It will simply ask for the resource group name, provide that, and click on confirm delete. Great. So all the best with your batch inferencing pipeline and have fun. Once again, thank you so much for watching.